The set ADT is nice because I can store a bunch of elements and then I can check if a given query exists in the set. I can add stuff to the set, remove stuff from the set. But one limitation is that I can just store elements. However, in the real world, I often want to map some sort of value with my elements. So for example, let's say I have a bunch of students. Let's say here are my students. And I have, for example, Nima, Felix, and Ryan. Well, okay, that's nice. I can store the names of my students, but if I'm a teacher, I probably want to store some other values that are associated with each student. For example, what if I want to store, so let's say these are the names. Let me move that a little bit further up, or yeah, there we go. Names. So these are the names. But what if I also want to store their grades? So maybe Nima has an A+, Felix has an A, and Ryan has an A. Let me draw some lines to make it more clear. So not only do I want to store the names of the students, but I also want to have some value that's associated with each of these students. So I want to map these keys to some values. The map ADT allows me to do exactly this. So the map ADT, it allows me to store multiple key value pairs. So keys are my elements, and then I can have some value associated with each key. So I can have values associated with each of my keys. Specifically, the map ADT is defined using the following operations. We have a get operation where given some query key k, will return the value associated with key k if k exists in the map. So for example, I could do get Nima and it would return A+, because the value associated with the key Nima is A+. If I did get Aaron, this would return null or false or some type of a failure indication because the name Aaron does not exist in this list. Now, what if I want to add a new key value pair? I can use the put operation, which maps a given key k to a given value v. So for example, maybe now I want to add Savannah. I can add Savannah, and let's say Savannah also has an A+. I've added the key value pair Savannah A+. I can also update an existing keys value. I could say put Ryan A+, and even though Ryan already exists in my map, this will update its value. So I can add a new key value pair, or I can update the value as associated with an existing key. And lastly, I have a remove operation. So remove, given some key k, will remove key k and its value from the map. So for example, if I do remove Savannah, it'll say, oh, okay, here's Savannah. Let me remove this key and its associated value from my map. If I do remove Eric, Eric doesn't exist in this map, so my remove operation would somehow let me know that it didn't succeed in removing Eric. It would either do nothing, it might crash, it might throw an error. Somehow it'll indicate that I was unable to remove. Or it could just not indicate it at all, just do nothing. So this is the map ADT. It's very similar to the set ADT. Really, we can imagine with respect to the keys, we basically have a set storing the keys. but we now also have an added value. And once more, I want to emphasize I have not given you any details about the implementation of any of these operations. What data structure you use to actually store these key value mappings is completely up to the specific implementation of the map ADT. The map ADT just defines a series of functions.